All right. Hey, hello. I'm
Hello.
here with Dmitry. Do you want to introduce yourself?
I'm Dmitry.
And where do you work and what do you do?
All right. I work at Oracle Cloud. I'm a lead engineer for a project called OCI Cache. We basically offer managed Redis and Valkey. We have a lot of customers, and in my copious amounts of spare time, I run Seattle Valkey Meetup. I used to run Seattle Redis Meetup, but then this little thing called COVID happened. So we resurrected ourselves as a Valkey project and a meetup. And I also contribute to Valkey project by maintaining the Rust SDK for developing of modules. So modules are extensions to Redis or Valkey, and you can write them in C, C++, or Rust. And I maintain the SDK that makes it easier to do so in Rust.
Yeah, I've seen that firsthand. We do Bloom, for example, and some of the other modules that have been added to Valkey.
Yes. Yeah, so there are a couple modules under the Valkey umbrella, and that is LDAP and Bloom filter.
Yeah, and hopefully we'll add more.
Hopefully get more.
We've been working on time series and hopefully more deterministic and non-deterministic data structures. So I wanted to talk to you about your talk that you had
Sure.
today at Unlocked about semantic caching. So can you tell me what are some of the benefits that you've seen for semantic caching in AI?
So semantic caching can help you significantly decrease LLM usage. Right now, there's this huge boom in AI where everybody's highly encouraged to do everything with AI. I personally think that in the near future, we'll have a cost of AI initiative at various companies who are going to say, well, how much is this actually costing us? Is this really delivering value? And we will have to re-examine how much we're willing to spend on AI, how many GPUs we can afford to use for AI workloads. And the way I think about it is like originally when databases became popular, people started writing lots of database queries and databases became overloaded. So there was emerged an idea that said, hey, what if we cache stuff? What if we don't go to database for everything? What if we take this data, summarize it somehow, and store it over here in some kind of a different data structure? And eventually Redis and Valkey emerged as a very common solution to that problem. I think similar thing will happen with LLMs. We need to find ways to make them more efficient. And one idea that I think can help is the idea of semantic caching, where you can simply not call LLM for everything. So you will store those queries for a period of time, and based on your similarity, certainty, or similarity threshold, you will instead retrieve these queries from the results from cache and never send the request to LLM. There are other approaches out there. There was a very interesting presentation by somebody who talked about LM cache technology, which can also benefit. So I'll be honest with you, I think it's very early in the process. Like, the whole AI revolution, it's only been the last, couple of years, less than that. Personally, I've been using AI for coding and other things for almost 2 years. But I think there will be some kind of solutions necessary.
Yeah,
And I think semantic caching is going to be part of it.
Yeah, and besides cost, sustainability as well, right? So you don't want to be burning so much electricity.
And just scalability, right? Think about it. If everybody starts using agents to do things that they used to do by hand, how many agents will you need? How many LLMs will you need? So even if you're willing to spend the money, there may not be enough GPUs out there.
I've seen people struggling, or some companies struggling with cost, and by implementing semantic cache, they've been able to reduce cost up to 85+%.
So I'm very curious about some of the specifics you said, because what I'm trying to do is I'm trying to find those specifics. I think the idea has potential, but it has to be applied at a large scale. You can't just run it on your laptop and say, look, I saved 5 queries to my LLM. That's not viable. But if you have a large workload where you have billions or at least millions of queries, and you save, let's say, certain 10, 20, 30%, that's when it can be a business value.
Yeah, and I think...
So you do?
I do, yeah.
All right, tell me more about it.
Yeah, well...
Now I'm going to interview you.
Yeah, actually, part of that is the corpus of data, right? So the more data you have...
Yes, absolutely.
That's when you get that knowledge base, and that's how you can actually take advantage of the semantic caching. Because let's say you do want to run a recommendation system for a streaming company, right? And they
say video streaming company of some kind.
Yeah. So essentially, what you're gonna say, you wanted now to ask it, hey, what movie should I watch next, right?
Sure.
And pretty much people have like, there's only how many 10 categories, right?
Yes.
So there's going to be 10
Action,
categories
comedy,
and your
romance.
history. Yeah. So that means that the more data you have from those millions and millions of users, the better the system gets.
Yes.
And this yields to my next question. What does a good similarity is? Like, what's a good point?
Based on just personal experiments, I think you need to go with at least 90%. Like if you lower similarity threshold to something as silly as like 10%, you will get just completely ridiculous answers. And yeah, so I think it's better to err on the side of having an unnecessary LLM call and having to then store that as a separate cache key value pair or vector value pair, but to give customer better results. It doesn't have to be perfect. Like in case of movie recommendations, maybe movie recommendations, then you say, no, I don't want to watch it, but that's fine. Or even in more like business settings. Let's say I am using LLM and I'm asking it all kinds of technical questions about a certain Java library. Great. And then you have a very similar question, but the answer is actually different, right? So the solution to my problem is not the same as solution to your problem. But you post your question, you get a response from essentially what was my cache, and you look at it and say, no, that's not correct. I have a different problem. As long as it's not complete garbage, I think it's still going to be a reasonable user experience. Like if you're asking it a question about some Java programming topic and it gives you something about Java coffee, that's probably where you dropped your similarity way too low.
Yeah, and that's exactly what I wanted to ask. Like, where does it break down? Essentially, it's that tuning, right? Where you reduce the similarity to low to try to get more cache, but essentially you just end up getting garbage.
Yeah, I would actually, in the cases like movie recommendations or technical questions, it's a pretty stable data. Like, they don't make movies every 5 minutes. If you watched the movie last year, you might want to see a similar movie today. So I would actually err on the side of increasing the TTL, but also increasing the similarity threshold.
Awesome. Well, thank you so much for your time, and it's great talking to you.
Likewise.